Hi, so today I'll be discussing the spiny beetle development network. We are given that the normal pathway for the formation of spikes is that S stimulates P, which stimulates I inhibits K, and K inhibits E then stimulates the formation of spikes. Arrows represent that the previous item must be present for the latter to be expressed. For example, for spikes to be formed, E must be expressed. The T bars represent inhibition. To fully grasp this, let's look at some examples. For our first problem, there's a mutation in P, and we will assume everything else functions normally. This means that P no longer stimulates I. Therefore, I is not expressed and no longer inhibits K, so K is expressed. K then inhibits E, and E is not expressed. This means that E cannot stimulate the production of spikes, and there are no spikes in this mutation. Our second problem has a mutation in I. This means that I cannot inhibit K, so K is expressed. K is then able to inhibit E, so E is not expressed and is unable to stimulate spikes. So in this mutation, no spikes are formed. For our third problem, there's a mutation in both I and E. A mutation in E alone immediately tells us spikes will not be produced because for anything on the latter side of the arrow, the thing on the start side of the arrow must be present. Hypothetically, the mutation in I would cause a failure to inhibit K. K would be expressed and would inhibit E if it were functional. No expression of E would mean no spikes would be formed. For our last problem, there's a mutation in S and K. The mutation in S would cause a failure to stimulate P. Without P present, I would not be stimulated. With I not present, K would not be inhibited. This means K is present and would inhibit E. However, K also has a mutation. This means that K cannot inhibit E. This allows E to be present and therefore stimulate the formation of spikes. If K did not have a mutation, spikes would not form. For problems like this, it is easiest for me to work backwards. So if you are most interested in spike production, the most important piece is that E is present. Then work backwards from there to see if E will be present. Generally, the mutation towards the end is more important to the final expression, but it can be helpful to work all the mutations fully. For the application of this knowledge, it is important to understand why this regulation is important. For the spiny beetle, spikes provide protection from predators, but spikes are not present in all ectoderm cells. If all ectoderm cells produce spikes, reproduction would be hindered, along with mobility in general. Also, in humans, ectoderm cells form part of the nervous system. If this also applies to beetles, they would not want spikes to form inside of their bodies.